Okay guys, now we will look at full wave rectification. So I will explain how you get these voltage values. Okay, now guys, so here you can see the sine wave we are feeding to a transformer. So then output side again we have sine wave but step down. Okay, now okay, like you can see each time we can see two diodes conducting, right? So in this pink color you can see the current flow. So it's go like this and go through the load, because now this D4 is reverse biased and also D3 is reverse biased. We can't follow that path. Go through load, then come into ground. Ground is connected with this D2 diode again. Then we forward bias D2 and going back to the transformer. That is how we complete this circuit. Now you guys can see each time we had two diodes conducting. That means guys, voltage drop, it should be, that is equal secondary minus 0 point, not 0 point, 1.4. That is how we get this equation. Clear guys? Okay. Okay guys, now that is this voltage. That is the voltage at this point. Okay. Now, and the ground. That means guys, that voltage is same as voltage between these 2 points. You guys agree with me? Because this is this node also connected with this node also connected with the ground. That means voltage between these 2 points, it is Vp out. Okay. Now we need to find PIV rating. Okay. So PIV rating means voltage between these 2 points. And when D1 diode is conducting, what will be the voltage through this one? How we find it, guys? Now guys, so you can see we have voltage drop through this diode as well. Okay, D1. When you add this D1 voltage difference to this one, then we should get this voltage drop through D3, or maybe not exactly voltage drop, voltage difference between two terminals of the D3, because we only have these three elements, right? D3 and D1. We know the voltage between these 2 points. Now, in order to find, because when it comes to this point, we have D1 voltage drop as well. Okay, if you remove that voltage drop from this term, we should get PIV rating. Saman I equals PP out. Okay, so that means guys, tell me guys whether you can understand that. I discussed this yesterday as well, guys. Okay, Cool, guys. Okay, now that is how we explain it. Okay. Okay, cool, guys. Okay. Okay, just take a bit of time, guys, and see whether you guys can understand it. Sorry, guys. Like, I had to check my son. He's eating his breakfast. So I have toddler at home. Now we have to deal with all these challenges. Okay. Okay, guys. I hope you guys got it. Uh, okay, guys. Now, in my activity that given, so you guys need to assemble all three type of circuit. I know some of you have multi-sim standalone version in your computers. Okay, so but you can try it online version as well, because yesterday, guys, I explained how you do that one, and I asked you to try different filter capacitors as well. Okay, I saw you guys like show you. When we replace different capacitors, we can increase that ripple, the reduce the ripple, and so on. It changed, right? So this ripple voltage after the filter stage, it is all about fixing capacitor. Like, so it depends on the filter capacitor that we use. Okay. Now, this is how we quantify that ripple. Just look at this equation. Okay. What are the important parameters, guys? We have frequency, we have load resistance and capacitor. VP rect. VP rect mean, guys, like rectified voltage. So earlier, so we discussed about output voltage for like half wave rectification. Rectified voltage is just V primary minus 0.7. Full wave rectification, VP primary minus 1.4. Likewise, that is the rectified voltage. Okay. So then, what is this frequency, guys? Frequency of what? For example, just think like we are rectifying 50 hertz signal. Now, for half wave rectification, what will be this frequency? For half wave rectification, here you can see example, what will be this frequency? When we half wave rectify 50 hertz utility power, what will be the ripple frequency? Uh, Guys, it is 50. Yeah. Reason. So sine wave mean, guys, sine wave mean some curve like this, right? So this one, some curve like this. Okay. So now this is one cycle. So because frequency of this one same as that original frequency, so it is 50 hertz. Okay. But what happened when you look at full wave rectification? When you look at one cycle, you can see two ripple cycle. So because of that, yes, good. It should be 100 hertz. Okay. It should be 100 hertz. Correct. Now load resistance, that is whatever the resistance that you connect. See, that is the smoothing capacitor that you fix. With that one, guys, you can get this equation here. Okay, with that one, we can calculate what is the ripple. Okay, then guys, uh, VP rectified minus half of the ripple, we get our DC voltage, half of the ripple. Why we consider half of the ripple? So in our when we have ripple like this, guys, this half voltage mean we consider some value around this one, this middle line. Okay, so so this is the ripple. Okay, ripple voltage. This is the half of the ripple voltage. When we subtract VP minus half of the ripple, we get this rectified DC voltage. Is that clear, guys? Okay, cool, guys. This is like VDC. That is equal, not different to like VP rect minus peak to peak ripple divided by 2. Okay, guys. Now that is what we have converted to this one. Because when you multiply one with this one, you get this term, right? Small thing, guys. Mm, so I have messed with this one. VP rect minus VR. Yeah, this is the idea. Tell me, guys, whether you got it. DC voltage mean rectified voltage minus half of the ripple voltage. That is what expressed by this equation. Guys, you all got it? You all got it, guys?